Hi everyone, this is Rakshita BK studying at Sri Venkateshwara College of Engineering, Department of Electronics and Communication. Today I am going to discuss about the modulation techniques in the evaluation of wireless communication from 1G to 5G. Let us see the introduction, history of wireless communication, evaluation of wireless communication, modulation techniques in the evaluation of wireless communication from 1G to 5G. Now we'll see what is the introduction. Modulation techniques serve as a fundamental building blocks in the realm of wireless communication, shaping the transmissions of information across the airwaves. As its core, modulation involves the strategic alternations of certain characteristics of a carrier signal, such as amplitude, frequency, or phase. To encode data for efficient wireless transmission, this process is crucial for overcoming the challenges of signal propagation and interference inherent in wireless channels. Has wireless communication has progressed through generations from 1G to the current 5G standards, modulation techniques have evolved significantly. The transmissions from analog to digital modulations with advancements like quadrature amplitude modulation and orthogonal frequency division multiplexing has not only increased data rates but also improved spectral efficiency. In 5G, modulation techniques continues to play a pivotal role supporting innovations such as massive MIMO and low latency communication. Understanding and optimizing these techniques are essential for evaluating and enhancing the performance of wireless communication systems in our interconnected and data-driven world. Next, we'll see the history of wireless communication. The history of wireless communication is intricately bound with the development and refinement of modulation techniques. It in its earlier stages during the late 19th and earlier 20th centuries, basic amplitude modulations to enable the transmission of telegraphic signals over radio waves. As wireless communication progressed, frequency modulation, that is FM, emerged, offering improved signal quality and paving the way for radio broadcasting. The mid 20th century witnessed the signal quality and paving the way of radio broadcasting. Application of modulation techniques in the realm of mobile communication with the introduction of first generation cellular network utilizing along analog modulations for voice transmission. The transmission to digital modulation techniques such as phase shift keying and quadrature amplitude modulation become prominent in 2G, subsequent generations providing more efficient use of spectrums and enabling the integration of data services. In a 4G era, orthogonal frequency division multiplexing played a pivotal role enhancing data rates and spectral efficiency. The ongoing evolution into 5G continues to see the refinement of advanced modulation techniques enable unprecedented data speeds and shaping the trajectory of modern wireless communication. Now we'll see the evolution of wireless communication. The evolution of wireless communication, particularly concerning modulation techniques, is integral to ensure the efficiency, reliability, and adaptability of communication systems over the years. Advancement in modulation have been pivotal in meeting the evolving demands of wireless networks. The transition from analog to digital modulation, coupled with innovations like quadrature amplitude modulations and orthogonal frequency division multiplexing has significantly enhanced data rates and spectral efficiency. The evolution process involves assessing how well modulation techniques accommodate the increasing demand for high bandwidth, lower latency, and improved signal quality. As we move into the era of 5G, the evolution focuses on the integration of advanced modulation schemes like 256 QAM and their ability of harness millimeter wave frequencies. This assessment ensures wireless communication system continue to meet the diverse needs of modern applications from high-speed data transfer to ultra-reliable, low-latency communication, solidifying the foundations for the next phase of wireless connectivity. Now we'll see the first generation, that is 1G technology. 1G wireless communication modulation techniques plays a fundamental role in enabling voice transmissions over analog networks. Amplitude modulations and frequency modulations were commonly used in 1G system. These modulation methods allowed analog signals representing voice conversations to be modulated onto carrier waves for transmission. AM and FM modulations were key to encoding and decoding audio signals, facilitating the establishment of basic model voice communication during the initial generations of wireless networks. The efficient utilization of modulation techniques was critical in providing reliable and widespread mobile voice services, marking the beginning of the mobile communication era. Next, we'll see the second generation, that is 2D technology. In 2G wireless communication, the role of modulation techniques involved as digital technologies replaced along systems, phase shift keying and frequency shift keying become prevalent in 2G networks, marketing a shift towards digital modulation. Global system for mobile communication are widely adopt 2G standards employed Gaussian minimum shift keying as its modulation scheme. GMSK is a form of continuous phase frequency shift keying optimized for efficient use of bandwidth along for more reliable digital data transmission over the airways. The transition to digital modulation in 2G provided several advantages including improved voice quality, increased capacities, and the ability to incorporate data services, laying the foundation for the future evolution mobile communication technologies. Now we'll see the third generation, that is 3G technology. In 3G, wireless communication modulation techniques continue to play a crucial role, emphasizing the transition to higher data rates and improved spectral efficiency. Multiple modulation schemes were employed in 3G network, with the most notable being quadrature amplitude modulation and phase shift keying. QAM allowed 3G networks to achieve higher data rates by encoding multiple bits per symbol, enhancing spectral efficiency. Additionally, adopt modulation and coding techniques were introduced in 3G, enabling the network to dynamically adjust modulations and coding schemes based on channel conditions. This adapt approach improved system reliability and throughput. The utilization of advanced modulation technologies in 3G contributes to enhanced data services, multimedia capabilities, and overall performance settings the stage for subsequent generations for wireless communication. Next, we will see the fourth generation technology. In 4G wireless communication, modulation techniques plays a pivotal role in achieving higher data rates, improved spectral efficiency, and robust performance. Orthogonal frequency division multiplexing emerged as dominant modulation scheme in 4G network. OFDM divides the available frequency spectrum into multiple orthogonal subcarriers, allowing simultaneous transmission of data streams. This technique mitigates mitigates the effects of multipath interface and provides high spectral efficiency, making it suitable for high-speed data transmission. Multiple input and multiple output technology combined with advanced modulation schemes such as 16 QAM and 64 QAM future enhanced data rates and systems capacity in 4G. The efficient use of modulation techniques in 4G contributes to the widespread adoption of mobile broadcast services, using in an era of faster internet access, improved multimedia streaming, and more reliable wireless experience. We'll see next fifth generation technology. In 5G wireless communication, modern techniques continue to be pivotal for achieving unprecedented levels of performance in terms of data rates, latencies, and continuity. Several key aspects highlights the roles of modulation techniques in 5G. Higher order modulations, millimeter wave frequencies, massive, that is multiple input, multiple output. Higher order modulations, 5G introduced more advanced modulation schemes like 256 QM, allowing for the transmissions for more bits per symbol. This results in high data rates essential for the increased demand for data intensive application. Then millimeter wave frequencies, 5G utilizes millimeter wave frequencies and efficient modulation techniques such as quadrature amplitude modulation and crucial for handling the challenges posed by these higher frequency bands, include increased susceptibility to attenuation and atmospheric absorption. Multiple input, multiple output 5G extensively employs massive where numerous antennas are used for transmission and reception. Modulation techniques combined with beamforming technologies optimize communication in massive MIMO system, improving both convergence and capacities. Conclusion. In conclusion, modulation techniques plays a pivotal role in the real of wireless communication, shaping the frequency and reliability of data transmission. Then the diverse array of modulation methods such as amplitude modulation, frequency modulation, and phase modulations allows for tailoring signals to meet specific communication requirements. Through careful evaluation and selection of modulation schemes, wireless systems can optimize data transfer rates, mitigate interference, and enhance overall spectral efficiency. The continuous advancements in modulation techniques contribute significantly to the evolution of wireless communication, ensuring improved signal quality, increased bandwidth utilization, and heightened performance in modern communication networks. Thank you.